Okay, this video now is going to show you how to find the choke size for a particular well. Now we're going to combine what we did in lab 7 with the template you just created to calculate flow for chokes. Okay, now I'm going to use the example. I'm going to ask you to use your lab number 7 to find the right choke size. I'm going to show you from my own example. I did one where the operating flow rate, yes, my own case, the operating flow rate came to be 1647. Now, so let's go. When we are using what we did in lab 7, you have to, let's look at the problem again. The wellhead condition is going to be the upstream condition for the choke, because the choke is connected to the wellhead. So now let's look at it. My own wellhead, the wellhead pressure is 800 and the wellhead temperature is 80. So that's going to be the upstream pressure and upstream temperature for the choke. And what else? I also need the specific gravity. The specific gravity is 0.65. So those are the things I need for the template. So let's go back. I'm going to open the template. So I'm going to change. Okay, the wellhead pressure is 800. Okay, I'm going to use the same K value, 1.25. The wellhead temperature is 80, I think. Yeah, 80. So that's going to be my upstream temperature. Then the specific gravity is 0.65. Okay. I'm going to use the same K value, 1.25. Okay. Then I'm going to, because the tubing diameter was 2.259. So I'm going to connect it to a flow line. The flow line starts from the wellhead, connects to the choke, and runs to the gathering system or directly to a separator. So let's look at this data. Then how can I use this to find the choke size? The first thing I want to do, like in the template, I already created another line. You find it in the template, which I didn't talk about. Critical pressure. The critical pressure is the critical pressure ratio multiplied by the upstream pressure. Okay, what you're going to do, you know that the highest flow rate you can get is the critical flow rate, which is going to be when the downstream pressure is less or equals to the critical pressure. So what you're going to do is just choose a pressure that is lower than 443. In this case, it's 443. Okay, so I'm going to, let me use 400. Okay, so I'm going to keep. Now you have to verify this. If I use 400, check your flow regime. See, it's sonic. So your flow has to be sonic. So the maximum. Okay, this is what I'm going to do. Let me start. We're going to use the bin type choke. You know, the bin type choke comes in increment of 1/64 of an inch. So I'm going to create a table here. You probably don't even need the table. The bin choke starts from number 4. Number 4 means 4/64. Number 5 means 5/64. So actually I'm doing, so I'm creating a table here. 4/64, I calculate the actual inch here, which is equals 4/64. That's 0.026625 inches. I'm doing in increment of 2, 4, 6, 8, 10, 12, because I don't want to do run for. So what I'm going to do is I'm going to start changing the choke size until it matches my operating flow rate. Remember I said the operating flow rate we calculated in my example was 1647. 1647, yes, 1647. And I think in your own lab 7, it will be like 8180, something like that. So what you're gonna do is you're gonna fill in this. Your wellhead pressure will now be your upstream pressure. Wellhead temperature will be your upstream temperature. Then you can use the same K. Normally I have to give that. You can use 1.25. No, use 1.3. I think I gave you 1.3. Use 1.3. That's going to recalculate my critical pressure. My critical pressure is now 436. It's still okay. So 400 is still okay. So we're going to use 1.3 K, 0.65. Then we're going to use also 2 inch. That's the more common one. That is the upstream diameter for the choke is 2 inches. You know, it's coming from the tubing is 2.259, so it's okay. So the flow is going to run into the 2 inch. Then it's going to be restricted to the choke size. So we're going to try to change what we are going to try to do is change the choke size here and check the flow rate. You want the flow rate to remain sonic because that's the maximum flow rate you can get. So until you get this to equals to what is the one from lab 7, my operating flow rate is 1647. Yeah, 1647. So I'm trying to get to 1647. So I'm going to start changing this. Let's look at the first bin number 4. Bin number 4, the diameter is 0.0625. That gives me 200. So I'm going to increase that. Naturally, to be fast, let me see. Let me use number 16. The diameter for number 16 is 0.25. So let me use number 16. It's the same operation when you are trying to find n, the value of the n exponent. So you're going to be changing this until we get to the operating flow rate. This is 1570, so we are going to 1647. So that's number 16. Let's use number 17. Number 17. Number 17, the diameter is 0.265. 0.26. 5625. 5625. Okay, so let's see that. Wow, number 17 is too big for the choke because I want to get to 1647. Now it's 1729. Now the thing is, because I'm trying to use a bean type choke. This is a nozzle. Okay, let me also tell you, when you are using the bean type, you have to make this one nozzle, okay? You have to put one there. Okay, so I'm going to use, which one is this? Number 17. Number 17 is too big. And we already tried number 16 is too small. But it's better to use number 16 because number 17 you cannot be producing greater than the highest, which is 1647. I don't want to produce higher than that. So the nearest one is number 16. So my choke size is, I'm going to use a bean type of number 16. That's it.